guys, so another edition of the Hoback shop. We're just working into about midway through finishing machining all of the A10s and OSFs that we've been working on for the last, I guess, 3 weeks now, 2 weeks now. Been machining at least. We've been waiting on parts left and right. Rescheduling a few things just because we've had some delays with machine shops and this, that, and the other thing. Disc grinding was a little behind because we lost the box at UPS, so that took a while. So we got lock inserts and backspacers coming this way. I figured I would go ahead and take this time to show you guys some of my fixturing and how I rough out my bevels on the mill. I've had a lot of guys ask me how I do it. You guys have seen it a little here and there, but I've never really gone in depth. I recently changed the way I fixture the parts and how I have them actually cut. I actually switched over from using a plate to having all the parts water jet. So we're switching that over. We're getting that all squared away. So it's Sunday out in the shop. I'm just kind of putzing around, getting a few things done, finishing up the last 3 A10 blades, and I'm going to switch over and build a fixture for the OSF blades. So I'll show you kind of how I fixture it and what I use to machine the blades. So what we got here, I was on my last 3. I ended up scrapping 1 in the beginning, so my last number of blades was 3, so normally I do 4 on here. The basic premise is they come water jet with tabs on the ends here. So these bolt holes here, they actually hold these little precision ground shoulder bolts that I get from McMaster-Carr. They're a 1/4 inch shoulder with a 1032 thread, just a little Allen key on top. You can torque them down really nicely, really tight, so that's helpful. So what I do is you have the 2 tabs on the ends. So I do this is the second op. This is actually the flip. The other side of them works out to do the bevel. It does all of the stop pin track, detent, pivot hole, and lock face all in one op so that it's all really accurate and all relative to each other. And then once that's done, I flip it. I rough this top spine out and then run a finishing pass on it, and then I put this screw, it's just a 1/4 inch bolt with a washer, and then I also run a shoulder bolt through the pivot hole, and then I also have these shoulder bolts in each end of the tabs. Then I do all of the work I can and then part those off and do a finish pass. It works pretty well. So let me pull these off and I'll give you a little closer look at them. Okay, so what we got going on here is, bear with me here, trying to get this cord out of the way so you guys can't get stuck in the middle of your field of view. So the bevels come, they're about 80% or so roughed out. As you can see, it's a fairly rough pattern. I think it's a 20,000 step down, I believe I'm doing. I'm actually using same cutter Grimsmo uses. It's just I think it's 6mm, 7mm, something like that, toroidal, I don't even know how you pronounce it. Just uses these little metric round inserts. I can rotate them about 3 or 4 times before they're wore out, and this one's kind of chipped out a bit. I've been running them really hard, just as roughing passes, so I don't really care if they chip. I've been getting them pretty cheap lately, about $1 a piece, I think, so it's not bad. So it's real stubby. It's only probably, I don't know, 3/4 inch stick out, so it's nice and rigid, so I can push this thing real hard. It's only got 2 flutes though. I really wish it had 3. 4 would be awesome, but this small, I highly doubt anybody makes one with 4 flutes or 3 flutes for that matter. I might step up size eventually, but it's easier to fixture with a smaller end mill. So back to this blade. Sorry, the lighting's a little funky here. Let me get some. There we go. Turn that lamp on. So this finish here on the flats is double disc ground. I just switched over on this batch to double disc grinding, and it's been just beautiful. I mean, this finish is pretty much what I would leave the blades at from surface grinding when I surface grind them, so it's pretty nice. It's probably a 400 grit finish if I were to take a belt to it. So I've saved myself a few little hand finishing details on the blades. I'm doing a finish profile with an end mill, which turns out pretty decent. After it comes back from heat treat, I'm still gonna have to hit it on a belt, but it's real clean. And I'm fixturing these in such a way that I can machine the stop pin track, the detent, the pivot hole, and the lock face all in a couple of one after another operations. So that makes sure that they're all relative to each other, so they're all the same. So I did 65 of these blades, and I can run a precision ground 1/4" rod through all the pivot holes, and they all line up identically. So that's really nice, because that allows me to make the frames very, very tight tolerances. So it allows easier fitting with a lot less hand fitting per every part. So I can actually catch up on my order books and send you guys knives. So I leave the edges about, I think that's like 70 or 80 thousandths thick. So you can see it's pretty beefy. But I grind these in by hand when it comes back. Or actually, I've been using a jig lately. It's been saving my neck. So like I said, this side, there's the 2 tabs here in the fixture. It drills the ends of the stop pin track and reams them, and then it machines out the web. Drills, reams pivot hole, drills the detent hole, cuts the lock face with an 8-degree 1-inch radius 4-flute carbide end mill. You can kind of see it, and I think I've showed you before. It just makes a concave lock face here. And then it runs through, does the bevel, and then I flip it. I chamfer the insides of these with a 1/4" chamfer mill. All of this. Flip it over, and in this operation, I run through, profile the backside, put that bolt down, put a bolt through here, and then I still have these 2 bolts on the edges of the tabs over on the edges. And then it runs through, profiles everything where there aren't any tabs, chamfers edges, does the bevels, and then I lock it down again just to verify, and then I part off those tabs. And then the knife comes off pretty cleanly. So I've been pretty happy with that. This is the same way that Daryl Ralph cuts his blades. A few other makers that I've talked to. I've just been doing a bit of masterminding, figuring out the most efficient way to machine blades. So this seems to be it, and I've been just absolutely astounded at the accuracy I've been getting. So we'll move on to frames, and I'll give you guys a rundown of how that goes. I'm going to give you an idea of how this fixture actually looks underneath. So the second op puts this 10 thousandths below the surface outline, basically, when it's profiling. The first operation actually sets, like this, opposite. And what we have underneath, you can see here, is the shoulder bolt goes in here. Let me lift the camera a little bit so you can kind of see this a little better. Zoom out. There we go. So I have a shoulder bolt location here. This is the first op where it drills and rings the pivot hole, so it's got nothing in it. But on this one, when you flip it over, the pivot hole lines up with this shoulder bolt. Works pretty well like that. The detent, the stop pin, I actually put a stop pin into this hole here. There we go. And it kind of helps locate the blade, and it keeps it from moving if it ever decides it wants to shift. Gives it a dowel pin to push up against, so works pretty well. So yeah, hopefully that'll give you guys some ideas if you're getting into machining blades like this. Might be a good idea for you. This section here is for the lock when I cut it. So since this is 3/16 stock, I actually drop, with my 1-inch radius 8-degree taper mill, I drop 145 thousandths down into the fixture, and it gives me the perfect radius that I needed for these lock faces. So, yeah, I guess that's about it. Let's move on. Alright, so I've been terrible about keeping up with the videos here, but I'm trying to get better. We've got all the blades done, and they're shipped off heat treat along with the lock inserts. So we got all that squared away on this A10 run. Now we're just machining frames. I'm machining A10 frames, and then I'll switch over to OSF frames, and then we'll do backspacers. So as you can see here, same setup that I do with blades. This is the first op, so it just does all the pocketing, all the setup for the lock insert, bearing pockets, stuff like that, and then I'll flip it over and run the other side, and it'll profile everything out. But so far I'm really liking the way it does this. Not sure how long it takes me, or I'd tell you, but I think it's about an hour or so to do this inside. So I just kind of sit here and change tools. I really need to buy an automatic tool changer, but Meg comes out quite a bit and helps me change tools while I do other work, so that works out really well. some stuff for blade show we got going over here. Let me change batteries in the camera, and I will show it some to you in this disaster I call a bench. Okay, so now that we've got battery changed, since I seem to have to do that quite often, we got a whole load of pocket clips blanks from Waterjet. So I have to build a fixture and machine these, clean up the profile and machine the logo, and then we'll go through and bend them. So that was always fun. There's probably 300 or 400 of them in here, so we're gonna do all of these, and we will take some to blade show. I actually had a pretty good idea. I'm gonna make some of these into keyring setup. So I'll machine them all out like I would with a normal pocket clip, put a split ring on there, and y'all be able to buy them to put them on your keyring if you want them. So we got that. Let's see. A couple of old, some of you may recognize these if you've been with me for a while. Some old prototype knuckle dusters from back in the day. Oh, my little pan of Damascus here. We've got a couple of zipper pulls in here that I need to finish heat coloring, setting up. Some Damascus, just a pile of Damascus here, so I'll make some cool stuff to bring to the show for you guys, some little knickknacks. I know that's pretty popular right now, so we'll put some stuff out. Oh, what else do we got here? Digging around. Oh, I finished. This is what the A10 frames will look like. This is set up for an inlaid version, obviously. It's all pocketed in there. But all the milling done and everything. Really light. I posted up a picture on Instagram. I actually take a little over half of the weight from this Waterjet blank to this. It's actually less than half the weight of this one. I did some FEA analysis on it in SolidWorks and determined that the way I designed this, I'm able to actually keep 95% of the structural rigidity to it and maintain the strength of that frame with all this pocketing and less than half the weight of a blank from Waterjet. So I was pretty happy with that. I really try to engineer things over just doing things. And that's why I recently switched over to not doing the bolster lock style that I used to do, and switched over to a drop-in inlay. We will actually, as a side note, be selling replacement inlays, so you'll be able to have access to a bunch of different colors: G10, carbon fiber, lightning strike, Damascus, zirconium, whatever. We're going to be machining that stuff out, so look to that. But as I said, I try to engineer it so I maintain the strength. With that old bolster lock version, it just reduced the strength so much that it just wasn't what I was after and what I want to offer to the public. So I set that up. So now these frames are just as strong as the weakest point of this knife, which unfortunately is always the lock relief. And I actually machine this lock relief a little differently now. It's hard to see in the video, but these are 8 thousandths tall, or excuse me, 12 thousandths tall ribs. And it allows me to keep a little bit thicker lock relief that isn't too hard to move over, but also maintains a little bit more strength. And with moving the lock face a little further forward, I actually was able to bring the force of the lock almost straight parallel along the lock bar. So that was really helpful in aiding in strengthening the design. FEA analysis is your friend with that, so it's pretty nice to be able to set that up and see where things are going to break and then go test it in the real world, and it actually works out the exact way that it did on the computer, which is really cool. Also, I found a great new way to save some time. We've been using a Lowe's Cobalt brand cement mixer for a tumbler. It's nice because it's got a nice plastic barrel. I think I showed it to you guys in previous videos, maybe not, I don't know. But we got about 150, 200 pounds of ceramic media in there, the little triangles and cylinders, and it does a really good job, but you have to sandblast everything first to get the milling marks out and the grind lines and everything out, and then you throw it in the tumbler. Well, I realized that, well, what's the point of sandblasting it if there's got to be an easier way? Because sandblasting, it sucks. I really dislike sandblasting. It's a pain in the butt. Probably has something to do with the fact that I got a really cheap sandblaster. Just a little cabinet blaster. So what I did is I put about 3 or 4 pounds of sandblasting media, garnet, into the tumbler along with the tumbler media and a bunch of water and some detergent to keep it from sticking together. And this finish, as you can see, looks identical to my sandblast stonewash finish. So I was super impressed with that. So that saves us a whole lot of time, which in turn gets you guys more knives. So that was pretty cool. So if you guys have any questions, you can always email me. I'm always happy to help if you're looking to do the same thing. Just send me an email. I can give you the details on it. You know how it is. I'll try to respond as quick as I can. You never know. We're pretty busy out here. So we got the new lock insert version here. Now this isn't machined down to thickness, so bear with me here. It's just partially machined. It was a leftover. But this little setup here is a boss that rides in here. So it gives me a press fit for my insert. Now, mind it, this isn't finished, so it doesn't fit in there right yet. And then, yeah, you still have your over travel prevention. The HRD screws right into this and the insert, and then there are 2 screws that also hold it down, so it's very secure and you can't barely see it, which is kind of cool. And it's much simpler to machine, so we're pretty impressed with that. All that stuff's out to heat treat, so I'll show you some more of that when it comes back from heat treat and how it all fits together, but it's a lot easier for me to fit that stuff together. So I've been pretty happy with the way that's turning out. I gotta name it something after my wife, since she came up with the idea of running a flat insert over those 3D machine ones that I was doing. So we'll have to come up with a name. Alright guys, well I'll get back to you as soon as something new happens. So there's something that I wanted to talk to you guys about. If you're into machining at all, which I love machining, it's really fun. There's something you don't really hear a lot about, and I'm always constantly scrounging the web for information, new ways to machine things, new tooling, things like that. But probably one of my bigger struggles is dealing with accuracy, and the last few runs I've managed to squeak out some amazing accuracy out of the machine. And what I'm finding is you get, I guess you'd call it cutter compensation. I don't really know the word for it, but basically different materials spring away from the cutter at different rates. So what you end up getting is some of them will be, like you'll try to machine a wall and the cutter will be running in here and the material is actually pushing away from the cutter as it's trying to push through and cut. So you get deflection from the tool, and then you also get deflection from the part. You get that in the Z and you get it in the X and Y. So compensating for that. Now, none of these pockets are really need to be very accurate. There's not any accuracy component to them, so it doesn't matter as much as this bearing pocket. This bearing pocket needs to be 0.06775D. Okay, so I maintain that accuracy by testing. So I'll run a couple of parts, I'll fiddle with it, I'll set my tool height a little differently, and I'll play it again, and I'll play it again. So after 4 or 5 iterations, I get perfect. So this bearing pocket is 0.06775D, as best as I can measure. So to do that, you have to test. So just a little tidbit, I do a lot of testing for spring back, different materials. Titanium is a weird thing. It's not conductive at all, so it heats up real easy. It's sometimes it's a little gummy, just depending on the batch that you're getting it from, and also it likes to deflect, so it's hard to set the cutter offset properly on these. So just something to think about. Lots of testing before you do things. Alright, so sorry I haven't been updating much lately. Blade show coming up. This is our power hour, so we're cruising right along with everything and trying to get everything done for the show and maintain orders and all that fun stuff. So I figured I'd just give you a rundown and then I'll post this video up. Got a few 3D machined 810s that we're going to be taking to the show. These ones aren't going to be part of this run. We already talked to everybody and got their finish options, and this is more of a like totally crazy one-off, barely had the time to do kind of things. But this is the Dragon scale. It's fully 3D machined into the frame. Even textured the lock relief. So there's this guy. We got OSFs, so we're making some OSFs here. Different pivot, 3D machined, and bam, a Hoback axe. These ones turned out pretty cool. That is a lot of programming. It's like 500,000 lines of code to put that in the mill. This is insanely hard to do. I think I scrapped 3 sets of frames trying to do it. They're over here. It's difficult sometimes setting your height offsets when you're doing this and maintaining hole tolerances. Like, that's supposed to be a stopping hole. It's not actually supposed to go all the way through. So, whoops. But they turned out pretty good. So these ones are scrapped. They'll be up for paperweight sales. With any luck, I think somebody will like to have these because it's got the logo. They turned out really neat. I like it. I'm really enjoying doing the 3D machining. So we're cruising through these. We got the stuff for the show going. These are all A10 orders. Got to finish. All the insides are finished on these. We just have to do the outsides. So we'll finish that up soon as we get back from the show. It's already the oh heck, I don't even know what the date is. We've been working 16 hours a day. Let me check my watch. Looks like 25th. So yeah, we got to figure that out. We might have some time to work on the knives once they come back from the show. Got a couple squared away here for orders, but these are the last of the ones that are going to the show. Some inlay ones. We did 3D machining on the other ones that we're taking to the show, like the Dragon Scale one here. I did a couple of Starburst pattern ones that I think guys will like a lot. What else is going on here? Right now we're just running another batch of OSF 3D machine frames, as you can see. And I need to clear the titanium chips out of here. I think we've been making a few chips. This thing, poor little Tormach needs a bath. It's been running for about 10-12 hours a day for the last 2 months. So it's been getting a workout. So yeah, so we clean up all the insides, deburr these on the Scotch-Brite wheel, put the finishes on them, clean up the edges. I gotta make some backspacers for these, but they're pretty easy on the OSFs. We're still trying to get together the drawing, or not the drawings, but the video work for releasing how to build an OSF. Honestly, with the time constraints that I have right now, what I'm thinking about doing is just listing the files, posting the files on my website so that y'all have access to them, and then you can kind of start building from there. We got a semi-roughed in tutorial going already, and I might just list it kind of as incomplete and update it as I can, just so I can get this information out to you guys, because I know a lot of you guys have been chomping at the bit to get this, and I just honestly haven't had the time to get it posted and finished because we've been so insanely busy. But I apologize for that. I will get that out. I know it's been like a year, but I need to do that. Moving on, what else do we got going here? We got to work pocket clips next. We got a whole slew of them. All the pivots, they just need to be cleaned and polished. Got a few different kinds in here. Let me see if I can dig some out. Here we go. I think I showed some of this to you guys, I don't know, on Instagram, but focus. There you go. Kind of a Starburst pattern on there. And we got another Starburst pattern we got here, and then we got the normal one, or so we got these all machined out. Got a couple of spiral patterns in here. I think I got one right here. Oh, there it is. Kind of swirly. So, turned out kind of neat. It's fun playing with the programming on that. OSF blades, lock inserts. These bad boys are so much easier to fit to frames compared to the old 3D machine lock inserts. they fit nice. See if I can get that off there with one hand. Maybe not. I do a real light, like a heavy slip fit through this boss right here in the titanium, so I machine all this pocket out. And when I grind it, it looks like that. You can barely see it. Turned out pretty good. So I've been enjoying working with these. Got the over travel prevention nub. HRD threads into a hardened steel insert, so that's always nice. Yeah, so they turned out pretty good. Well guys, blade show's coming up, so I don't know how much more time I'm going to have for video. Hope you guys have been having a good time. Sorry I haven't been doing videos lately. It's been insane around here. We are getting Hoback production in line. They're telling us that we should have parts, all the parts shipped out here next week, but I'll believe it when I see it, because I've been having enough trouble getting my hopes up having them ship me stuff when they say they're going to, but they've been really struggling with new machines and people and equipment and all that stuff, so I'm trying to cut them some slack. They're going to get all that stuff to us, and we did find a new machine shop that can get us stuff, all of our parts and stuff, in a good time frame, and they can actually do it on the time that they tell us. So we're really looking forward to working with them. So the machine shop that we're working with now is, they blanked out pivots for us already. We did all the final machining and all the intricate stuff here, but they blanked them for us a lot cheaper than we were buying them for in the exact length. So that was pretty cool. That saved us some time there. And they've been doing things like that for us quite a bit lately, and they're on time when they do it. Kind of at my whim. When I ask them, they provide. So it's been awesome. We're really looking forward to dealing with them on the second batch of Hobacks. And also, we have a special announcement here soon. There's going to be another knife that's going to be coming out, so you guys look forward to that. I'll leave you in suspense with that, because I don't know, it's kind of fun to leave you guys in suspense. I know you guys will dig it when it comes out, but I don't want to announce anything until I actually have product, because we're definitely trying to change the way we run a business. We've been having too many problems with giving time frames and then not being able to keep it, just because of problems we have with different vendors and things like that. So what we're going to do from this point forward is we're not going to pre-sell, we're not going to take deposits, we're not going to do any of that stuff. It's just going to be listed on the website, and it's first come first serve. Saves us all a lot of hassle, and lets you guys get a lot of knives quickly. So we're really looking forward to that. Appreciate all you guys' support and all of your willingness to keep going along with me, especially with all the delays we've been having with the Hoback run, but I think you guys will think it's worth it. These first batch is pretty much going to be a semi-custom, just because we got to do all the finish work and all the assembly and sharpening and everything in-house. But we're going to try to get some out before Blade. I don't know if we'll get them all out, just because there's 400 of them, and that's a lot for me and Meg to put together. But we're going to do our best, guys. Alright, well, looking forward to seeing y'all at the show. Come by. 15A is our table number. Stop by. We'll be happy to see you and chat with you and live it up a bit. We'll have some knives with us. Alright guys, God bless.